So as I've discussed, scaling is very important when you're training a machine learning model. If you have numerical features that have different ranges of numeric values or have means that are quite different, you don't want certain features to dominate or bias the training just because of their numeric values. It just doesn't make sense, right? So you need to scale, and we talked about a couple ways to scale. In this demo, I'm just going to show you how to do z-score rescaling with the tools in scikit-learn. So a first step when you're scaling for training a machine learning model is you actually have to split your data set. And you need to do this before you scale because you want to use the scale of the training data, whatever those scale coefficients are, like in this case it's going to be mean and standard deviation since we're doing z-score. You want those to then be applied to your training features as well. So I'm going to split this data set. I'm going to create my labels. I'm going to create an index here that's the features, and I'm just going to do the train test split from the pre-processing package and create an index, and then I can just run through this index really fast, very efficiently, and create my training features, my training label, which is I'm calling X-train, Y-train, my test features, and my test label. So let me just run that for you. All right, doesn't produce any output, so it's not very exciting. So now we've got to scale those data, but recall, we're just going to scale the X-train, the numeric features from the training feature data set, or NumPy array, I should say. So yes, keep in mind these are NumPy arrays. So from the scikit-learn pre-processing package, we have standard scalar, and we're going to fit that with the .fit method to this, and it's only the last three columns, so it's 14, 16 that are the numeric columns in this. The rest are categorical features. And so we've defined the scalar based on this standard scalar. We've fit to that training data. Now we apply the transform, again to the same training data, the same three columns of the training data. And we do the same thing with the test data, but notice we're using the scalar that we fit here on the test data. So that's an important point. It may seem subtle, but it's important. And we'll just look at the first 5 rows of those 3 numeric features. And you see they do look scaled. They're all, in a pretty narrow range, and if we made histograms of them, you would see in fact they are zero-centered and have a standard deviation of 1. So thanks to the nice features in scikit-learn, it's really very easy to scale data. The pitfall being, make sure you split the data first, train the scalar on your test data, or I'm sorry, on your training data, then apply that scale you've learned from the test data to the training or evaluation data. So you need to do things in that order. So the workflow matters here, but actually writing the code is very easy.